Hello everybody. In this video I want to show you guys how to use Excel to do the calculations for our density lab. You'll notice I already added in some data here. A couple of things to mention about this data. These volumes and masses here, I've already done all the math required with the final and initial values on the burette. And I've subtracted out the mass of the flask. These are in fact the volumes and the masses of our samples alone. I did all the other calculations off of Excel. We did the measurement lab last week, so you guys should know now how to be able to do that and be able to take it this far on your own. The other thing you'll note is that this data is different. If you receive data from me, this data is going to be different than that data, and that's intentional. I don't want you guys to just directly be able to copy exactly what I'm doing here. I want you guys to be able to take your own data and reproduce this on your own. So the first thing that we want to do, because this is the density lab, is we're going to calculate the density of these different samples here. So we're going to make a density column. We're going to give it units, grams per milliliter. We're going to include one down here. And we're going to calculate our densities. So densities are grams per milliliter. So let's take the grams and divide it by the milliliters. So I'm going to take this mass here, and I'm going to divide it by this mass here. I'll hit enter. I get my value there. And now I can drag this down. And I will even double click this one just to make sure that it's doing what it should be doing as I go along, that it's in fact dividing this column by that column in the proper cells. You notice I already formatted this so that it's giving me 4 significant figures. This might be a step that you're going to need to do for yourself. I'm getting the 4 significant figures from the volume. These are all 4 significant figures, so that's what our limiting that's what's limiting the significant figures that we can get over here if we use our convention. I'll come down here and I'll do the exact same thing. And you can notice here I am going to have to format this one. I'll come here, number, and I'll make sure that that's a 2. Or I'm sorry, that should have been a 4. There we go. All right. So the next step is for us to make the plot for our known samples. So we know what the percent mass of these guys was, and we know what the density of them of these were, and we want to make a plot of the mass versus the density. And to do that, what we're going to do is we're going to come here and we're going to insert one of these XY scatter charts. Okay. Now, if you know something about Excel, you know that you can go ahead and highlight these beforehand, and Excel will put it into the XY scatter plot for you. But that's not super reliable all the time. It's not really great always at knowing what is the X's and what are the Y's that we want to have. So I'm going to show you how to just add a blank chart, and then you pick what your X and Y is going to be. So we have our blank chart here, and we're going to right click on it. And when we right click on it, we get a bunch of different choices here, and one of them is going to be right here. It says select data. If I click that, I get this dialog box, which is pretty confusing. And I'll also mention it looks a little different on Mac. But I'm showing you the Windows one right now. The steps are pretty much the same. You just kind of have to get to it a little bit a different way, and it looks a little bit different, but in general it's pretty much the same. And what we're looking for here is this guy right here, okay, under the Legend Entries Series tab that says Add, okay? It's pretty much the only thing that isn't grayed out on here. So we're going to hit Add, and we get this dialog box. Again, pretty cryptic. We're not 100% what to do with this, but we do note that it says right here, Series X values, okay? And this is where we can enter in what our X values are going to be, okay? And our X values are going to be the mass percent. And our Y values here are going to be our densities. Now, if you're a little astute at this, you may notice in the next step that this seems a little backwards, that we might actually want to plot the X values as the densities and the Y values as the mass percent to make this a little easier for ourselves. And that's certainly true, but there is a convention in chemistry, and the convention is basically that our concentration values are always going to be our x-axis, okay? And having that convention is a little bit more important in the grand scheme of things than making a plot that's always convenient for yourself. And so that's how I'm going to show you how to do it. We're going to do the mass percents here, and we're going to do the densities as the Y value. So to add our X values, we're going to click this little up arrow here. Okay, and you see that it kind of just disappears here for a second. And what this is telling you is that now it's time when you can select what the X values you want are. So we'll just do that. We'll come over here and we'll highlight these X values that we want. And you can see that it populates what it's looking for in here. Again, a little cryptic. It's telling us that we're on sheet 1 and that we're going to go from A4 down to A8. Once you're done, you click this now down arrow here, and you have that values in there, okay? Then you have your Y values. You notice it already has this 1 in here, but that doesn't matter. We want that to go away. So we're going to click our up arrow here, and again, we're going to highlight these guys here. And then we'll click our down arrow. Now, the only important thing to note here is that I did these two in the same way. I started at the top and I came to the bottom. I came over here, I started at the top and I came to the bottom. If you don't do that, it's going to put them in here backwards and you're going to have them matched up. So like 20 will be matched up down to here and 30 will be matched up to that guy. So you don't do that. Top to bottom. Okay, just like you read. And that's pretty much it for what we need to do there. And we'll just hit OK. And then we get back to here and we'll hit OK here. And we see our plot now here. Now, there is some issues with this plot still. The biggest one being we don't have any label for what this X values are. We can see that they are right? Like we have 20 here and then 30 and then 40. And then these values seem consistent with the densities. So we plotted it right, but we need to put labels in here. And to do that, you come up here to this guy here that says Quick Layout. Again, if you're using a Mac, it's in a different spot, but I don't have a Mac to show you. You're just going to have to look around for it a little bit, but Quick Layout. And what I did is I just chose the very first one. It's pretty much usually pretty good. One thing that it does have in that first choice is this series thing here that we don't need. That's fine. We can just click that, hit delete. It's gone. It's not going to bother us anymore. So now we want our chart title. And I often, when I'm not really sure how to title these, I just title them X versus Y, basically. So my X here is the mass percent of ethanol versus the density. And then I'm going to come down here and I'm going to click on this axis title here. You'll notice it also conveniently for you opens up this side thing here that you really don't need and is just kind of in the way. And I'm going to call this mass percent ethanol. And then I'm going to come over here. I'm going to double click, triple click that one. And I'm going to call this one density, and I'm going to put in the unit for that one, grams per milliliter. And now I have, let me get rid of this guy. I have a nice chart here, okay? And what we want to do is we want to use a technique called linear regression that's going to tell us what is the line that best fits this data here, okay? And it's going to be able to give us the actual equation of that line as well. If you guys remember from your algebra class, this is going to take the form of y equals mx plus b, where m is the slope and b is the y-intercept. In Excel, they don't call it linear regression, and they kind of make it a little tricky to get to. So what you're going to do is you're going to click on one of these points, and you're going to see that it highlighted all of them, okay? And you're going to right click, and it's got this guy down here that says add trend line. And if you click that, you get this side dialog piece here. So you can see that there's a couple of different kinds of forms of regression we can do, depending on what kind of function we want to fit to it. There's exponential, linear, logarithmic, polynomial power, moving average. We want a line, so we want the linear one. So the default worked just perfectly for us. What it didn't do by default, that I think is really a mistake and really should always be done, is it didn't display it's not going to display the equation or the R-squared value. We need these. I need to see these on your guys' report. So I'm going to turn those clicks on there, and you can see that they popped up there. Let's get rid of that for a second, and we can kind of move this to a spot where we can read it well. And now we have the equation of our line. Okay, so our y values are densities here, and the x values here are our mass percents of ethanol. And we also get this R-squared value. So R-squared is a value that tells us how well these points fit on the line that we got. Okay, and an R-squared value of 1 means that the points lie perfectly on the line. Okay, they're not if you plugged them in, they would just be right there on it. So that would be a perfect fit. It falls off pretty quickly after that. For proper research work and stuff, you really shouldn't have an R-squared value of less than like 0.898, 0.985 or something like that. You know, even for pretty low level work, R-squared value of less than 0.95 just really isn't going to be acceptable at all. You know, if you got a R-squared value of 0.5, you just aren't even in the ballpark. You don't have a good fit to your data. But we got an R-squared value of 0.99, so that's pretty good. So we got a pretty good line here for this. Now, in order to do this calculation that we need to do, what we're going to do is we need to input our density for our unknown here into y, and then calculate x from that. So we're going to have to invert the equation. And that's why I was saying if we had flipped x and y, it would have been a little bit more convenient for us. We could have plugged in x and just calculated y. But we're following our convention here, and inverting an equation like this really isn't that difficult anyway. The first thing I always like to do is to just kind of graphically give myself an estimate. Okay, so I know that this density here is 0.8950. So if I come over here, 0.8950 is right in between 0.9 and 0.89. Okay, and if I put my cursor there and I trace that across until I get to this line, okay, and then bring it down, this is the point, this is the x value that's going to correspond to it. This is the point that I'm looking for right here. And I can see this is past like 55. It's past the halfway point. It's not quite to 60. So I would say that's like 57, 58 or something like that. So that's kind of the estimate of what I should be getting. Okay. But we're going to properly calculate it now. But it's always good to have an estimate in your head as to what the answer should be near, so that you know if you made a mistake. Okay? So the first thing that would be convenient for us is to have both the slope, and that's this value right here. Okay? And the slope is actually going to have units associated with it. And those units are going to be the rise over the run. So it's our density units in this case, grams per milliliter divided by our mass percent ethanol. So this would actually be grams divided by milliliters times mass percent. That would be the unit that you would get. I'd like it if you guys kind of thought about that and proved it for yourself. Okay. And it would be nice to have this intercept right here. Okay. And so the intercept also has units, right? So you're going to be multiplying it by x, which is mass percent. So it has the same units. The y-intercept has the same units as the y-axis here. So I'm going to call this y-intercept. I'm going to give it its units, grams per milliliter. I'm going to say it equals that. Okay. Now I could just copy these down. Right? I'm going to just say negative 0.0019 here. And I could just put in 1.0061 here. And that would be fine. Okay. But Excel actually has a built-in function to do this for us. So what we could do instead is say equals slope, open up those parentheses, and you notice it says it wants y, comma, and then the x's. So it's backwards than anything I've ever seen. And why is that is true? I have no idea why they are doing that, but it wants you to put the y's in first. So our y's are the density. So we can highlight those. We'll hit comma. And then we can put in our x's. And you see that it also highlights these for us here. So we know that it's now accepting the x's. And we'll highlight our x values there. We'll close off those parentheses. And we'll hit enter. And you see that we get this value, but we also got like the extra digits there, the ones that it didn't display right there. Okay, so that's actually pretty nice. And you can carry all of those forward. Those don't have to figure into our significant figures or anything like that. So this is actually a little bit better for us, right? There's another function for the y-intercept. It's equals intercept. And again, it wants it as y, comma, x's. So first we'll do the densities, comma, and then the masses. And we'll close those off. All right, and you see that we get that number, but we got those extra digits too. Okay. Also notice that when I highlighted these and I put in the y's and the x's, again, I went from the top to the bottom, top to bottom. Okay, that's important. If you do it reverse, you're going to get the wrong numbers here. Okay. So now that we have that, we can do what the real goal of this whole lab is, which is to figure out what the mass percent of ethanol is based on the density. Okay. And again, we already did our estimate here. We know it's going to be like 57, 58, you know, some kind of rough number close to that. So let's put this in here. It's going to be the mass percent of unknown A, because that's the unknown I had. Whoop, we're in the wrong spot. And we have to put this in with our little equation here. So what is our equation? We're going to hit equals our y value. Y value is going to be the density of our unknown. Okay. So one of the density values. So we're going to click there. Now we got our y. Okay. To invert this equation, what we're going to do is we're going to subtract this intercept over first. Okay. So we're going to do minus our y-intercept. Okay. And then to finish our inverting of this equation, we're going to divide by the slope. Okay. Now we do have to add in here some parentheses around these guys to tell it to do those first. Otherwise, we're going to run into an order of operations problem. Okay, but now we can divide by our slope. You can see that equation there. And if we hit enter, we get 57.1 essentially. So yeah, I did a good job estimating there, you know, nailed it. So this is going to be our mass percent. We do have to format this to be consistent with our data. Again, we were having 4 significant digits that we were carrying forward there. So they should also have 4 significant digits, which would mean that it would have 2 decimal places, and there's 4 significant digits. So we are going to say that our unknown A, based on this data and this calibration curve, is 57.07%. And that's pretty much it. You guys will have an extra unknown to do in your thing, but now you should have all of the skills that you need to complete this lab.